Right, hello Year 11 and welcome to my lesson of the week, which is all about reducing, reusing and recycling and why it's so important. And we're going to be looking at some things that you won't have heard about, not just to do with the environment, but why else it's really important to do these things. So I'm going to start off with some definitions that are important. Some of these you will have come across before. So you will have done about renewable and non-renewable energy. So non-renewable energies such as the fossil fuels, so oil, coal, natural gas, are things that cannot be replaced. So they were made millions of years ago. Once we've used them, that's it, they're going to run out. Another term that we can use for non-renewable sources is that it is finite. Okay, so there is only a certain amount of it. Now, another finite resource that is non-renewable is actually nuclear energy as well, because we get that from uranium, which is a metal that is found in the ground. On the other side, we have got renewable energy. So these are things that can be replaced. So if we look at hydropower, for instance, that comes from water that builds up in dams. You've got things like the water cycle that are constantly recycling that resource. Renewable energies won't run out. They can be used over and over again, so they can be replaced. So those are two different ways that we can define types of energy or types of resources, if they're renewable or non-renewable, or if they are finite, which means that there is only a certain amount left of it. Okay, so some good examples of finite resources are ones that you will know about, so fossil fuels like oil, natural gas and coal, but ones that you might not think about are all of the metals. So there's only a certain amount of each of the metals on Earth, and once they are used, then that's it. They are completed, they're done. Also building materials, so things like limestone, which they use in concrete. There's only a certain amount of limestone. There is only a certain amount of iron for steel, which is used a lot in building materials. There's only a certain amount of resources to make glass. There's only a certain amount of resources to make the different metals, so copper is used quite a lot, iron, things like that. So all of the metals are finite, building materials are finite, as well as the ones that you will have come across before, which are the fossil fuels. Here are some examples of common renewable resources. So these are ones that can be replaced. So one renewable resource is wood. So we can burn wood to create heat, is renewable because you can grow another tree and then use that. Sugar is a renewable resource because that comes from plants. So you have sugar beet and sugar cane. That's where we get sugar from. So you can just grow more sugar plants to get your sugar. The sun, even though, yes, it will eventually die out, it will take billions of years for that to happen. So we count that as a renewable resource. The sun is constantly giving us heat and light. Okay, now the next few slides are going to be about reading graphs. From the exam questions we did on potable water, there are still people that are having issues with reading graphs. So here I've put a graph, and I'd like you to read the information, have a look at the axes and the numbers that are on it, and can you have a go at saying what this graph is showing? So pause the video and write a sentence. What is this graph showing? Okay, so hopefully we've had a go at that. Very straightforward answers. They're showing how many years are left of three fossil fuels. So 113 years left of coal, 55 of natural gas, and 53 of crude oil. And these predictions were taken in 2013. So here's a prediction. Why do you think that it is difficult to accurately predict how many years are going to be left of these three fossil fuels. So have a think about it, pause the video and maybe pop down 2 reasons why you think it's very hard to predict. Okay, so you've had a thought about that. One of the reasons why it's very hard to predict is that there might be new technology developed to get more fossil fuels. So better drilling equipment, better mapping of what is underneath the Earth's surface to find more fossil fuels. There might be new technology to make current fuels last longer, so making it more efficient. And there also might be more developments of renewable power sources being developed. So, for instance, we need crude oil to make petrol, but now cars are starting to move towards being electric as opposed to run on petrol or diesel. So that will mean that less is being used of crude oil. So it's very hard to make these predictions because we don't know what is going to happen, what technologies are going to happen in the future. Okay, here's a different graph, and there's going to be 2 graphs, this one and the next one, that are going to be very similar. So I want you to pause the video and I want you to try and work out what this graph is showing. Okay, and just write a sentence about what is this graph showing. Okay, so it's got a lot of information on this graph. So you can see that on the y-axis, you've got the estimated percentage of resources left compared with 2011. This is looking at 2036, as you can see at the top. So in about, 15 years. You can see that the bars go up to the percentage. So if you look at aluminium, it's between 90 and 100% that is left, and that it's predicted to last 1,787 more years. We can see that gold is predicted to be depleted at 2027, lead 2031, silver 2034, and tin at 2031, and the others have got varying degrees of years left in them. This is looking at the resources if the rate remains at the current level. So that means if we are using them at the current level that we're using them at the moment. Okay, so it looked complicated, but hopefully we worked out what each of those means. So the next one's going to be pretty similar. You've got the same X and Y axis, but it's got a slightly different description. So I'd like you to pause the video and I want you to think what this is showing and how it was different to the last one. So pause the video now. Okay, so hopefully we've had a look at what this one's showing. So the last one was using the current levels. This one is increasing the levels at the current rates. So we're using more and more resources every year because there's a bigger population, new technologies, etc., etc. So this is looking at the projected rates and how much will be left. And you can see that aluminium's gone down a huge amount. So it's predicting only 56 more years of it. Cadmium depleted in 2036. Many others will be depleted by 2036 or before 2036. And all the others have got rather depressing number of years left in them. So even platinum has only got 83 more years left. Now, these resources that are listed at the bottom, you might be able to recognise some of them and its importance. So aluminium is used a lot in alloys. It's light, it's strong, it doesn't corrode because it makes a special layer over the top of it. Copper, obviously used in copper piping and wiring. Gold, not just in jewellery, it's used a lot in microchips as well. Graphite is used in electrodes. Lead is used in quite a lot of alloys. Nickel as well is used in a lot of alloys. Tungsten is used in lights, It's also used, tungsten tubing is used in X-rays and things like that. Uranium to produce nuclear power, and then obviously oil, gas and coal. So one that you might not be familiar with that I didn't mention is cadmium. Now this one went down a huge amount and it's actually used in rechargeable batteries. So with all of the technology in cars, for instance, going to rechargeable batteries, it means we're going to be making a lot more rechargeable batteries, which means that we're going to run out of cadmium, which is very important in rechargeable batteries in the not too distant future. I've also put on there petrol. So if we keep going at the current rates, 11 years oil is going to run out. So that's petrol, plastics, they all come from crude oil, diesel, kerosene for aeroplanes. What are we going to use instead? It's not that long away. Now, what the point of giving you all that information is trying to illustrate to you why it's so important that we recycle. So not only is it good for the environment, we're going to look at that, but it's also really important to reuse these finite resources. Otherwise, we're just not going to have anything left. So there's three kind of terms that are used: reduce, reuse, recycle. So reducing is just using less of the resource or making it more energy efficient to make. Reusing is when you're using the resource again, so reusable bags, things like that. So it means that you're not making new ones every time. And then the big one, recycling, that's really, really important because it means that you can use that resource again. And also we're going to have a look at it reduces the environmental impact because less energy is needed to make it from scratch. So I've got two really important examples to talk about. Both of them are metals. So this is the first one. This is how we would get iron from iron ore. Okay, you would use something called a blast furnace, which is basically a big oven where they pump in really, really hot air. They get that from burning natural gases. And you basically melt the iron ore and react it with coke, which is carbon, and you end up with molten pure iron, which is obviously what you want to use it as it is or to make things like steel. Now it takes huge amounts of energy to burn those fossil fuels, so not only are you using the finite resource of iron, but you're also using the finite resource of those fossil fuels, both of which will eventually run out. If you recycle iron, so cans, food cans, things like that, or car scrap, things like that, it saves 50% of that energy. So it's 50% less energy needed to recycle iron than it is to extract it from its starting point. So huge amounts of carbon dioxide that doesn't need to be released because you're not burning fossil fuels. Huge amounts of money saved as well, and obviously it means that we're not ploughing our way through that finite resource. So if you want to pause the video and make any notes on that, then that's absolutely fine. Otherwise, I'm going to move on to my next example. So my other example, which is a really important one and links very, very well with a previous chemistry topic, is aluminium. So each person uses about 8 kilograms of aluminium per year. But every year we're using more and more and more of it, as we saw from the earlier graphs. It's really, really important that we recycle as much aluminium as we can. Unfortunately, things like aluminium foil that we use in cooking is quite hard to recycle because you're meant to get rid of all the food waste off it first, which obviously could be cooked on quite stubbornly for people to recycle. Really important that we recycle it because not only is it conserving that limited resource again, so we saw that aluminium is being used more and it is going to run out sooner than currently predicted, but also it uses 95% less energy than extracting it from bauxite. And that's the link to a previous topic, which is electrolysis. So to extract aluminium from its ore, we use electrolysis, to extract it from bauxite, the ore. And that requires huge temperatures because you have to get it in its molten state. So 95% less energy is needed if we recycle it. The picture I've just pulled off Google Images, you can see that there's still a process where you have to melt it. So step 4, remelting it when you're recycling it. But it's still much, 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 much less than what you would have to put in energy-wise if you were purifying aluminium from electrolysis. So I've put here a quick summary of the main points that we need to take from this lesson. So first of all, we rely on the Earth's natural resources to make new products. And there's lots of products that we get from the Earth. Pretty much all of them come from the Earth. Some of those are finite, and that means that they'll eventually run out. Some of them are renewable. That means they can be replaced. It's really hard to estimate how many years are left of fossil fuels because it's very hard to predict future technologies and if they find any reserves that we didn't know about. Not only is there social and economic, but there's also environmental issues involved with exploiting Earth's resources. So that means exploiting and using Earth's resources. So it has effects on environment, so loss of habitat, global warming, things like that. Obviously economic, because you're making money. That money can be given in poorer countries, things like that. There are also social aspects as well to consider in terms of where people are living and opinions on that. And most importantly, the last one, recycling metals saves energy, but it also saves a finite resource. So that's it from me. It's quite a short section, this one. If you wanted to have a look in more depth, obviously you can find information in your revision guide, but also there is information in the textbook which you can find on Caboodle. Okay, that is it for me. So I hope you are staying safe and well, and tomorrow you'll be having a lesson with Miss Slade where you're going to be looking at LCAs. Okay, that's it. So thank you very much and goodbye.